Hello! In this tutorial, I will be showing you how you can find the height of a building given the amount of time it takes for an object to drop from the top to the bottom of the building. And I will be showing you how you can use derivatives to find the speed of an object at any given point of time. Let me demonstrate. Imagine that you are on top of this building and you drop a ball from there. You timed the fall and it lasted 6 seconds. How tall is the building? And at what speed did the ball hit the ground? So the initial speed is 0 meters per second, and we want to find the height and the final speed. We know that the gravity equals to negative 9.81 meters per second square. It is negative because it is going downwards, and in math, the graphs downwards will be negative. The function for height equals to a half times the gravity times t squared minus t2 squared. T2 is the amount of time it takes to fall, and this t is a variable, so we can choose any number for here and substitute that in here. The function for the speed is the derivative of the function of the height. Over here we have this graph. This is the height per second, and the speed is if we want to find the speed of the ball at this point, we find the tangent of that point. And the tangent of that point, if we go straight down to this derivative line, will be over here. So if we want tangent of this point, we go straight down to its derivative line, and then the y-coordinate of this point here will be the tangent of this, will be the slope of the tangent of this point here. To find the derivative line, we derivative this function. So we have this derivative. A half and g are constants, so we take those out. Now we have the derivative of t squared minus t2 squared. And since t2 squared is also a constant, the derivative will when we derivative it, it will disappear. And the derivative of t squared is, we take this power sign, we put it here, we subtract 1 from the power sign, so it's 2t, and we get gravity times time. t1 equals to 0, t2 equals to 6 seconds. The height equals to, over here we have this function, we substitute the numbers in, and we get 176.58 meters. The final velocity of the ball equals to the gravity times t2. So we get negative 58.86 meters per second. Since this is going downward, it's negative. Now let's have a look at our Python program. First, I will run this. Enter the time in seconds. In our case, it was 6 seconds. Here they give us this graph, and the height of the building is over here, and the speed of the ball when it touches the ground is over here. This point is the point at 6 seconds, so we can see that the speed is negative something and the height is 0. First, from the matplotlib module and the pyplot package, I import the matplotlib.pyplot as plt for shortcut, and I import numpy as np for shortcut. From Scipy module and the MISC package, I import derivative. T2 will let the user input the final time in seconds. Gravity is negative 9.81. Here I define the height function. So here is t, we return half times gravity times t squared minus t2 squared. The function for the velocity is the derivative of the height. And x, here we have the x. X equals to np dot linspace 0, 10. This means np is the numpy module, and when we call np dot linspace and we pass in two numbers, they will take the first number 0 and then slowly add more and more to the list. For example, 0, and then the second number in the list is 0.1, 0.2, all the way to 10. So we get a list of many numbers from 0 to 10 to get an accurate graph here. Plt.xlim 0, 10. This means that I want my graph to start from 0 and end at 10. I can choose a different number if I like. Plt.ylim negative 300, 300. So I start from negative 300, and here I have 300. Plt.plot x function the height function with x inside. So the x is a list for the coordinates of x, and here is a list of all the coordinates for the function of x. The height function. So, and I label it height. And over here, plt.plot, this will be the derivative line. First I have the x, which is over here, and then for each x, the y coordinate will be the function of it. Plt.xlabel, time. So over here I have this time, and the y label is height. And then plt.legend will just give us this box here so we can see the labels. Plt.scatter t2 and the h function t2. The scatter function will give us a dot, and I want the x coordinate of the dot to be t2, so it's the time we input, and the function t2 for the height. So the y coordinate is over here, and do the same thing for the derivative line. First I dot the t2 for x, and then the y coordinate of this dot will be the derivative of that function. Finally, I print the height of the building is, here h0 means when the height is 0, we want to find, that 0 is the time. So when the time is 0, we want to find the height of the building. And this function will give us the height of the building when the time is 0. And the speed of the ball when it touches the ground is the velocity at the final time. Now, here I define some other functions to show you that Python can find the derivative of any function. I define this function. It will return x cubic minus x squared plus all this. So it will be hard to find the derivative of this using a pencil and paper. Here I define another function. This will be the derivative of this function. So return the derivative of that function and x. X equals to np.linspace 0, 5. You know that's a list from 0 all the way adding up to 5. Here I have the graph I want from 0 to 5, and the y coordinate is 0 to 60. Plt.plot. Here I put in this list of x coordinates, and this will be the list of y coordinates. And do the same thing for the derivative line. Let's run it. Here we have this squiggly line. And this plt.scatter, I want to find a point where the x coordinate is 2. So when the x coordinate is 2, over here they show us the y coordinates. And plt.legend will give us this box. This is the end of this tutorial. If you have any questions, requests, suggestions, please leave them down in the comment section below. Please subscribe to my channel. I upload a new video every day. Today is January 24th, 2020. Thank you for watching and have a nice day.